Hello everybody, in today's video we're going to take a look at calculating the Laplace transform for cos AT and the Laplace transform of sine AT, where A is just some constant. Okay, so for this method we're going to make the most of Euler's identity, which tells us that e to the I, usually use theta and use AT, is equal to cos AT plus I sine AT. Now, by taking the Laplace of both sides, so if we take L of both sides, what do we see? Well, let's check it out. So we have the Laplace of e to the power IAT. That's on the left. On the right, using the linearity of the Laplace transform, we can write this as L to the Laplace cos AT plus I L sine AT. Okay, so the left-hand side is the thing that we can use from previous examples. We know the Laplace of the exponential function. The first term, this is what we're trying to figure out, and the second term, we have an I there, but next to the I is something we also want to figure out. Okay, so let's start with the left-hand side. So using example 2, this is an example I've already recorded, the Laplace transform of exponential function. We discovered that the Laplace of EAT is 1 over s take away a. So wherever number sits in front of t, in this case a, we have to subtract in the bottom half of the fraction here. Okay, so let's take a look at what we have. We have this. So using the result, the left-hand side is going to be 1 over s, take away the number in front of t, which is IA. Okay, so we're now into complex numbers, particularly division of complex numbers. So I'm going to rewrite this in the usual format by multiplying the top and the bottom by the conjugate of the bottom. It's just a bit of complex numbers here. It's the top, s plus IA. The bottom is s squared plus a squared. And I'm going to write this as, let's see, s over s squared plus a squared. That's the real part, plus I a over s squared plus a squared. That's our imaginary part. And that deals with the left-hand side here. Now, simply comparing the right-hand sides, we can see the real part, well, this is the Laplace of cos AT, and on the left, the real part is this thing here. Similarly, for the imaginary part, the Laplace of sine AT, well, on the right-hand side, is just this thing here. So comparing both of the sides, what do we see? We see that the Laplace of cos cos of AT is equal to S divided by S squared plus A squared, and the Laplace of sine AT is equal to A divided by S squared plus A squared. And that is the end of our example. Thanks for listening.